Okay, so here's the second example that you provided me. And when you're factoring, you do always want to look for a greatest common factor first. Look for a GCF first. And in this case, all three terms are divisible by 3. And all three terms have at least one y in them. So I'm going to factor out a 3y. And then in my parentheses, I'm going to write what would be left over if I divided all those terms by 3y. So the first term would be y squared. The second term would be a positive 2y. And then the third term would be a negative 1. And I can always check by redistributing. So if we did 3y times y squared, that would give me 3y to the third. 3y times 2y would give me 6y squared, and 3y times negative 1 would give me negative 3y. So that part checks out. Then check to see if it is fully factored. And in this case, we want to take a look at this part of the polynomial and see if there's any values that would add to a negative, add to 2 but multiply to negative 1. And there's no way for us to multiply to that negative but add to the positive in this situation. So I think this example is actually completely finished. The only way that we can multiply to a negative 1 is to use a positive 1 and a negative 1, and those two values would not be able to add to a positive 2. So this one's actually finished. We can go ahead and go on to one of your next examples. Alright, example 3. Again, look for a GCF first. In this case, both terms have a w. They don't have any constant values in common with each other, no numbers that we can divide out, but we can divide out a w. And when I do that, that would leave me with 8 minus w squared. Again, we can check by redistributing, and then we want to double check to make sure whether or not what's on the inside is fully factored. If this was a perfect square, then it would not be fully factored. We could go ahead and do the difference of two squares. But in this case, 8 is not a perfect square number, and so we can't take this any further. So this one's also finished. Okay, example 4. I'm going to start the same way I started the others. Look for a greatest common factor first. And all three terms do not have a variable in common, so I can't factor out any x's. And 31 is a prime number, actually. The only factors that it has is 1 in itself. And so this is not going to have any greatest common factors other than 1. This is one where we want to use the AC method. AC, oh come on now, method. It's a quadratic trinomial with an a value that is not equal to 1. Not x, I wanted that to be a. Let's try that again. There we go. In this case, the a value is 12. So since this is a quadratic trinomial with the a value not being equal to 1, AC method is a good systematic approach to use in order to try and factor this. So first step, step 1, multiply the a and c values together. For this example, that means that we would multiply 12 and 2 to get a result of 24. Step 2, list all the factor pairs of that result. From step 1. So we need factor pairs of 24. That would be 1 and 24, 2 and 12, 3 and 8, 6 and 4, and then we also want to include all of the negative values as well. And so we could have negative 1, negative 24, negative 2, negative 12, negative 3, negative 8, negative 6, negative 4. And our goal is to try and find a factor pair of 24 that adds to the b value. Let me write that as step 3. Identify a factor pair from step 2 that adds to the b value of the polynomial. In this case, our b value is 31, and it looks like none of these combinations of numbers are going to add to that value. So I don't know that this one can be factored. Where did you get these examples again? I wanted to make sure I typed it down correctly. 12x squared plus 31x plus 2. That's what I have in my example, right? 12x squared plus 31x plus 2. Okay. Yeah, I don't think this one can be taken any further. So that means I still need to show you an example of one that can be factored using the AC method. Let me look one up here real quick. Okay, let's try this example. 6x squared minus 41x minus 7. This is still a quadratic trinomial, and the a value is not 1, so AC method would be an appropriate approach to trying to factor it. And I went ahead and copy and pasted these from above because we're still going to take the same steps. So we'll start by multiplying the a and c values together, which would be 6 times negative 7. And that would give me negative 42. And now I want to list all the factor pairs of that result from step 1. And it's actually not necessary to list all the factor pairs. Your goal is to just try and figure out which factor pair will add to the b value. And in this case, our b value is negative 41. So we want to identify the pair that adds to negative 41. I don't need to list all the factor pairs in order to figure out how to do that for this one. My very first factor pair will help me out with that. 1 and negative 42. And then again, we want to include all sign possibilities, so we could also switch that around and have the 1 be negative and the 42 be positive. So one of those is going to help me add to negative 41. If I want my sum to be negative, that means the bigger number has to be negative. So this pair is going to be my winner here. So for step 3, when I identify the factor pair from step 2 that adds to the b value, 1 and negative 42 are the numbers that I'm going to use. Those add to negative 41. Okay, step 4. I'm going to rewrite the expression replacing the middle term with the two values chosen in step 3. And the middle term, negative 41, has an x next to it. So when I use these values, I'm going to put x's next to these as well. Let me copy and paste this to make this a little bit easier to show what I'm doing. Okay, so there was my original expression. Now I'm going to rewrite that. The first term stays the same, 6x squared. But now instead of writing negative 41x, I'm going to write plus 1x minus 42x. I kind of think of it as uncombining like terms. If I were to go ahead and add those back together, it would get me back to negative 41x. And then the negative 7 at the end remains as it was. Now the whole purpose of doing this is to write this expression so that now instead of having 3 terms like we did before, we have 4 terms, which means that we can now use the factor by grouping approach. We can split these into 2 groups and factor by identifying their greatest common factors. So that's my next step, step 5, factor by grouping. I will bring this down here. Okay, so my first group of terms, 6x squared plus 1x, There are no numbers that I can factor out between those two, but they do both have an x. So I can factor out an x, and that would leave me with 6x plus 1. And again, I can redistribute to make sure that that checks out. X times 6x gives me 6x squared. X times 1 gives me 1x. Now with my second group, negative 42x minus 7, I can factor a negative 7 from both of those terms, but they don't have any variables in common, so I can't factor out any x's. If I divide both those terms by negative 7, then I end up with 6x for my first term and a positive 1 for my second term. And again, I can redistribute to make sure. Negative 7 times 6x gives me negative 42x. Negative 7 times 1 gives me negative 7. But now I'm in good shape, because if we look at what's inside the parentheses, we have 6x plus 1 and 6x plus 1. So I can factor again by factoring out the greatest common linear factor, 6x plus 1. And then in my second set of parentheses, we'll go what's in front of those parentheses. So in front of the first 6x plus 1, we had just an x. And then in front of the second set, we had a negative 7. And that is the final answer. That's the factored form of our original expression. The process actually takes longer to explain than it does to actually work through, I think. And once you practice it a couple of times, it starts to go pretty quickly. And I like this approach just because of how systematic it is. So I hope this helps with some of the ideas that you were struggling with, and feel free to shoot me another email, send me some more questions. If you are in need of more immediate response, you can text me at 314-420-9476. That way, if you still have more questions tonight and you need me to get back to you faster, let me know and I will get back to my computer and see what else I can do for you. Otherwise, I hope you have a good night.